In this video, we are going to continue looking at examples where we are finding intervals of increase and decrease. So we are going to look here at example 3. G of x is equal to x squared over x squared minus 9. First, we are going to find our derivative, g prime of x. That derivative, we have a quotient rule, so x squared minus 9, low d high, minus high, d low, square the bottom, and away we go. So we have negative 18x over x squared minus 9 squared. So that is our derivative. What are we going to do with this derivative? Well, we need to find out where is it 0 and where does it not exist. So it's going to be equal to 0 when the numerator is 0. So when that top part's 0, it's going to be equal to 0. So negative 18x equals 0 would tell us x is equal to 0. So that's one of our critical numbers. We also need to find out where g prime does not exist. That's going to fail to exist when our denominator here is equal to 0. If you were to set that equal to 0, you will find out that both 3 and negative 3 would cause that denominator to be equal to 0. So x equals 3 and negative 3. Those are places where our derivative does not exist. Now, I will mention here real quick, those are not critical numbers. Why are they not critical numbers? Well, they're not critical numbers because they were not in the original domain of the function. So those are points of discontinuity. Those are going to be vertical asymptotes. Those are not critical numbers. But we still need to split up our sign chart at those points. So we are going to go from negative infinity up to negative 3. We'll then pick up at negative 3 and go to 0. And then we'll go from 0 to 3. And then we will go from 3 to infinity. And we're doing a sign chart for our derivative, for our first derivative. So pick some value smaller than negative 3, so like negative 10. Plug in negative 10 here, and you will get a positive value. Right? That denominator is always going to yield something positive, because when you square it, that negative stuff will go away. So you have a negative 18 times a negative 10 on top. You'll have a positive on top, and you'll have positive on bottom. Next, pick something between negative 3 and 0, so like negative 2. If you plug in negative 2, you also get a positive value. Plug in something larger than 0, but smaller than 3, so like positive 2. You plug that in, you'll get a negative value, and you'll get a negative value here. So this tells us, oh man, I made the same mistake here. This should have been, in my labeling, this is g prime of x. And g, not the derivative, but g of x is increasing on negative infinity to negative 3, along with negative 3 to 0. And it's decreasing on 0 to 3, along with 3 to infinity. So that's the increasing and decreasing of g of x. All right, let's look at this final example. In this final example here, we have h of x. So we are going to first find our derivative. Our derivative here is going to be 4 minus x to the negative 2, which is 4 minus 1 over x squared, which is 4x squared minus 1 over x squared. And so if we get a common denominator between those two, this function, this derivative, does not exist when x is equal to 0. And our derivative is equal to 0 when the top part of that is 0. Which will happen when x is plus and minus 1/2. So the sign chart that we are going to create is going to go from negative infinity up to negative 1/2, from negative 1/2 to 0, from 0 to positive 1/2, and then from 1/2 on up to infinity. And this is for h prime of x. So if we plug in a value smaller than negative 1/2, and we are plugging that into our derivative, and you can plug it into any representation of that derivative that you might want to use, but if we plug in something smaller than negative 1/2, so negative 1, negative 10, plug something in, and we will find that the output is a positive value. If we take something between negative 1/2 and 0, so like negative 1/4, plug that in, we will get a negative. Plug in positive 1/4, you will also get a negative. Plug in something bigger than 1/2, and we will get a positive. So what does this tell us about our function h? So it is increasing on negative infinity to negative 1/2, together with 1/2 to infinity, and it is decreasing from negative 1/2 to 0, along with 0 to 1/2. And those are our intervals of increase and decrease. In our next video, we will talk about how we can use these things to try to identify maximums and minimums. We will see you there.